Now we're going to discuss about symmetry and dipole moment. What is dipole moment actually? Dipole moment will relates to polarity and it is a vector quantity. So if the molecule is having these two qualities, it must be symmetric, right? So molecules will divide into two types. One is molecules with the dipole moment, that is mu not equals to 0. Okay, and second category is molecules with no dipole moment, that means mu will be 0. If we see the molecules with the dipole moment, according to symmetry, which molecules will have the dipole moment we are going to know. So first point is molecules with only CN point group can have the permanent dipole moment. That is C2 and C3 point groups will have the molecules which are comes under C2 and C3 point groups can have the dipole moment. So hydrogen peroxide, so it comes under C2 point group, and this one tris glycinato cobalt complex will comes under C3 point group because this dipole moment can lies through the axis being its vector quantity. Next point is molecules with only sigma. That means the molecules will comes under CS point group will have the permanent dipole moment. So monodeutenated water, phenol, monosubstituted ammonia, all will comes under CS point group, so that these molecules can have the permanent dipole moment. Next category, molecules with CN and sigma. That means the molecules which are comes under CNV point group can have the permanent dipole moment. So water molecule being C2V point group and ammonia C3V point group and this one C4V point group. These molecules can have the permanent dipole moment. And next, molecules with only C1. That means asymmetric molecules will have the permanent dipole moment. So first the molecules with the CN, and next category molecules with the sigma, and next category CN followed by sigma, and next category only C1 point group. So the four types of point groups having molecules will have the permanent dipole moment. So our next category is molecules with no dipole moment. That means mu equals to 0. So molecules with the center of inversion will have no dipole moment because here the moment, the dipole being a dipole, when it produces the moment, it will be cancelled by the opposite side, right? So mu will be 0. That means the molecules which are having the center of inversion. So molecules which comes under C2H point group will have no dipole moment. D2H point group ethylene will have no dipole moment. The next category, molecules with more than one rotational axis. That means Cn followed by NC2. That means DN point group, DNH point group, DND point groups. The molecules which are comes under DN and DNH, DND point groups will have no dipole moment. So skew ethylene, it will comes under D2 point group. It will not have the dipole moment. And aleine, it comes under D2D point group. It have no dipole moment. That means mu will be 0.